Section 6.2. We're going to continue talking about our rational expressions and simplifying them and working with them. In this section, though, we're going to talk about the thing that we dread most about fractions. We are going to talk about adding and subtracting our rational expressions. In all honesty, I think adding and subtracting rational expressions is an easier process than when there's numbers. You might disagree with me on that, but I think that this is a little better. What we're going to do today is just the first half of the process. And then when we come back on Tuesday next, we'll do probably what's the harder part. So here's my first example. If I ask you to add these two things, 3 over 11 plus 5 over 11. So again, we're going back to middle school arithmetic, or whenever, I don't even know when they teach this. What is the essential thing to have if you are going to add or subtract any fractions? Same denominator, common denominator. The fractions have to be divided in the same number of parts. So where we're going to focus today is we're going to just go through the process of what do I do when I have like denominators. When we come back Tuesday, we'll talk about, okay, what happens if the denominators are not the same? How do I make them the same? So this is just half of the problem. When the denominator is the same, the process is, the process of adding is not hard at all if the denominators are the same. All you do is you're going to add or subtract. So this is 3 plus 5 is 8. And when I add, what do I do with the denominator once it's common? Nothing. You leave it over 11. Okay. So I don't think that's too terrible. So let's try this. Let's say I have 7 over 2r squared minus 11 over 2r squared. Is the denominator of these two fractions the same? Yes, it is. Okay, so that's going to be true. So when you go to do your homework for section 6.2, in the 5 days until you see me again, okay, just do the problems that say like denominators. Okay, we'll talk about, if you know how to do the unlike, go ahead and do those too, but we will talk about that and do plenty of examples on Tuesday. So the denominator is the same. That's fantastic. So 7 minus 11, what does my calculator tell me 7 minus 11 is? -4, 2r squared. We leave the denominator alone. You don't do anything once it's common. And then at this point, if you can simplify the fraction, you do. If you can't, you're done. What's the factor that I can reduce here? Yeah, 2. They both have a 2 in common. 2 goes into 4 twice. 2 goes into 2 once. And leaves me 1r squared, or just r squared in the denominator. Good. Question? All right, here's the next one. This one's for you. 6 over 5x squared plus, and add to that 14 over 5x squared. Go ahead and add those two, and if you can, simplify the results. Okay, so again, the common denominator is already there. So my numerator, 6 plus 14 is 20 over 5x squared. If you did that, you're great. Just make sure you simplify. 5 goes into both of these. 5 goes into 5 once. 5 goes into 24 times. And so I have 4 over x squared. All right, I've got one more example, and then I've got 3 more for you. And then any questions you have, we'll talk about. And that's going to be our stopping place, because that's where I stopped with my Monday, Wednesday class. I'm keeping you all at the same place. So here's an example for me. Let's say that I have something like x over x plus 6, and I'm going to subtract from that 7 over x plus 6. Just want to address the issue of what to do with the numerator when what you're adding together are not like terms at all. So we've got the common denominator here, x plus 6. what would you suggest? What's your hypothesis of what I'm going to write for my numerator in this problem? Yeah, there you go. It is what it is. I know that seems super simple, but sometimes it's not intuitive if you haven't seen it before. So it's just x minus 7. I can't simplify anything there. That problem's done. I've taken two fractions, I've smushed them together into one fraction. So I do that just because I didn't want there to be any consternation about any of your last examples. So here's yours: 3x over x plus 4, and then plus 12 over x plus 4. So on this problem right here, when I go to add, my numerator is going to be 3x plus 12. Okay, those are not like terms. I don't have 15 of anything there. Okay, I've got 3 x's, I've got 12 of something else. The denominator is x plus 4. If you've done that, you've done 75% of the problem. Great job. What remains is I've got to simplify, just like we talked about in the previous section. The top factors, I can factor a 3 out. 3x when I factor the 3 out leaves x. 12 when I factor the 3 out leaves 4. And the denominator of x plus 4. So I gave this problem, one of the reasons, in addition to talking about the addition, was what to do when my denominator cancels out. We saw in an earlier problem what to do when the numerator cancels. You put a 1 in the top and then your stuff in the bottom. But here my denominator cancels. So what I have is 3 over 1. But then our normal process is when you have a 1 in the denominator, we just write 3. Okay, that would be the proper thing to do. Here's another problem. X over x squared minus 9 minus 3 over x squared minus 9. Not a super difficult problem, but just gets us a little more practice. Okay, same thing as previously. My numerator is simply going to be x minus 3. The denominator stays the same, x squared minus 9. We simplified something very similar to this in the previous section. The top doesn't do anything. The denominator is a difference of squares. 2 factors of 9 are 3 and 3, plus and minus. And then I notice, oh, cool, I can cancel out the x minus 3. So this is another situation that we've already seen where my whole numerator cancels, but I have to notate that my answer is in the denominator, so it's 1 over x plus 3. All right, so if there's questions, ask them. This is the last problem that we're going to do in section 6.2, and we'll pick up what to do when the denominators are not like next time. In fact, on Tuesday, it's Common Denominator Day, so that's very exciting. I'll make a banner. All right, so last problem, adding. So I'm going to add those numerators. Now I do have some like terms that I can go ahead and work with. I've got a 5x plus a negative 3x. So 5 plus negative 3 is 2x's. Then I have 6 plus 4. 6 plus 4 is 10. And then my denominator stays the same. Once you have the common denominator, that's going to be all the hard work to adding and subtracting, is finding the common denominator. That's the thing we're going to practice a bunch of when we come back to class on Tuesday. Once you've done that, we're going to do a little factoring, we'll reduce, and life will be good. So we're going to factor out a 2 out of the top. 2x, I factored the 2 out, I leave x. 10, factor the 2 out, I leave 5. The denominator is a nice trinomial that we've seen a couple dozen of today. We've factored plenty of trinomials now. My two signs are both going to be different. And then the factors of 20 that are 1 apart are 5 and 4. I made 5 the positive one because the bigger number, the positive number wins. This is positive. And there's my x plus 5's in common. Great. And my final answer is 2 over x minus 4. Yeah. Can I simplify this? What would you want to do? No, it's a great question. I'm really glad you're asking. And I'm guessing what you would have said, if it didn't occur to you, is that you want to cancel the 2 and the 4. And I get it. That is the most common mistake on this next test coming up. And that's why I've repeated this over and over, is I do not want that for any of you. This 4 here is a term. It is being subtracted from the x. Because of that, those two things go together. Okay, you cannot just cancel parts, bits and pieces. It's an all or nothing proposition. Okay, so for that reason, I cannot take that any further. Okay, great question. Anything else?